So on behalf of OpenAir Collective, Dr. Srubar, thank you so much for joining us today. I'm Gloria See, electrical engineer who meandered my way into the algae space. I have a little startup with Logan. He's my co-founder, looking at algae as a carbon sequestration mechanism. Logan, feel free to unmute yourself and then get you on board, Dr. Srubar.
Howdy, my name is Logan. I'm again Gloria's partner in this algae-based CDR project that we've got going on, and I guess we're very excited to sit down and talk to Dr. Srubar here today.
It's really great to be here. Yeah, thanks for having me.
Thank you. So for those of you who perhaps do not have friends and family that emailed them many articles about you this summer, well, Prometheus Materials got, like Chris said, some well-deserved fame and attention. So you are a professor in civil, architectural engineering, and materials science at CU Boulder. Your lab is living materials. I am saying this as a question so that it's easy for you to correct me if I'm doing this on the fly.
Yes.
PhD from Stanford. Your BS and MS was Texas A&M and UT Austin. And so now what we're super excited to have you for is hear about your work on using carbon dioxide removal for biomimetic materials, living materials, and carbon storing materials. And then I thought one thing that was very cool is your Nsf Career Awards. So congrats on that.
Yeah, thank you.
Big deal. And then you're the co-founder of 3 startups. So Prometheus Materials is the one I'm most familiar with, Minus Materials and Arraeus. Is that correct? Arraeus Earth?
Yeah, Arraeus Earth. Yeah.
Arraeus. Cool. Could you give us kind of quick overview on the 3 different projects to get us started?
Yeah, absolutely. Again, it's great to be here today. So Gloria, thank you for moderating. You too, Logan, and Chris, thank you for inviting me. Yeah, absolutely. So, a lot of professors sit in their ivory tower for the rest of their life once they get here. But not me. I do believe that the things that we do in the lab have tremendous impact and application in the real world. 2 of the startups that I'm involved in right now are spinning out technologies that my lab had a hand in inventing. And then Arraeus Earth is a separate entity, but I can talk a little bit about that in a few minutes. Prometheus Materials is the furthest along. Prometheus just closed a Series A $8 million funding round to commercialize our living algae-based concrete technology. The premise of that technology is, there are a variety of microorganisms that make calcium carbonate, that make biocements. And so what Prometheus is doing is leveraging the capability of those microorganisms to create a biocement in situ that cements sand particles together and other aggregates. And so the resulting product has load-bearing capacity. The resulting materials have no Portland cement in it whatsoever. If you're familiar with the cement space, cement is responsible for 7% of global CO2 emissions. So Prometheus is really engineering a drop-in replacement for traditional cement-based materials. If you're familiar with a company called Biomason, it's a similar type of approach in which the final manufactured product is concrete-like, but it's not quite concrete.
Okay.
That company, and I can go into a little bit more detail as needed, but maybe I can switch to the other ones.
Yeah, let's hear about the other ones, and then we can dive in more detail as we go through.
Yeah, great. So Minus Materials, Prometheus is focused on making concrete-like alternatives and other building products with photosynthetic microalgae. But the premise of Minus is to use calcareous microorganisms that are very important to the global carbon cycle, like coccolithophores, that readily make a lot of the new limestone that's created on the planet every year. Minus is industrializing the cultivation of coccolithophores, and the whole premise being that the new calcium carbonate that is grown is really a form of CDR. It's a form of carbon dioxide removal and storage in limestone. And that limestone can be used by the cement and concrete industry to help decarbonize their production process. There's really two ways that you can use limestone in cement manufacturing. One is to make the cement itself. So right now we take limestone out of the ground and burn it, and off goes the CO2 that was stored in the calcium carbonate. What Minus is doing is growing quarries for the cement and concrete industry, and taking CO2 in as the starting resource, fixing that in mineral form, and enabling the production of lower carbon cement. The other way that you can use it is just as a filler, an inert filler. If those of you familiar with Blue Planet aggregates, it's a very similar approach, only we're doing it biologically, where we're growing mineral fillers and aggregates for use in any concrete product.
And when you say, it's a biological quarry, as you sort of describe it, where do you put that?
Like where are we growing it at right now?
Yeah, is it lab scale? Is it out in your backyard baby pool? Where is that living?
Yeah, absolutely. So like I said, Prometheus is further along than Minus. Minus is cultivating algae right now in, we scaled up our microalgae cultivation to about 1,000 liter photobioreactors at present. Minus is currently raising a seed round of funding to get to capacity of about 10,000 liters, again in photobioreactors. But there are certainly, the company certainly has a strategy to scale beyond that, of course.
And is that scaling, again, sort of in my little nerd space, are you scaling to more bioreactors or to open pond scale, or setting them loose in the ocean and harvesting little concrete modules from them out there off of their little oil and gas platforms? I have this whole algae utopia vision that I would love to see come to pass. So curious where yours are going.
Same. If you take a page out of the biofuels industry from the early 2010s, right, open ponds were the cheapest way to go. That was really the most economical way. And so in our techno-economic pathway for the company, we've analyzed open pond systems, we've analyzed horizontal vertical PBR systems, we've analyzed more closed, just batch kind of PBR systems. I can't tell you exactly which one we've decided on specifically, but what is exciting is that a lot of the lessons learned from that era of algae cultivation have been applied, and we're learning a lot, especially at early stages where those critical decisions have significant impacts on the outcome of the company.
Definitely, yeah. And then anyone who's not an algae person, PBR in this case is a photobioreactor and not a terrible beer. Just for that context for anyone watching it down the line. Did you want to tell us a little bit more about Aureus?
Yeah, so Aureus Earth is with Minus and Prometheus, it's kind of like having two twin children. Like they're very different, they have different personalities, but at face value, they may look the same, but they are certainly different. Aureus Earth is radically different. So Aureus Earth is really a carbon offset methodology developer specifically for the construction industry. There is right now they're also Aureus is an early stage, really pre-seed startup that is working very closely with stakeholders within the construction industry, large stakeholders, to develop carbon offset methodologies to enable rapid uptake of lower carbon and carbon storing building materials. The very first seminal methodology is a mass timber building protocol that quantifies and values and monetizes additional biogenic carbon storage in a building that would not have occurred otherwise. So I know not everybody is in the building space, but there's a critical time as a building owner where you have to decide, is my building going to be built out of concrete or steel, or now mass timber is a lever that we can pull to decarbonize the physicality of a building. But it's expensive in some cases. In some cases it's not, but in some cases it's expensive. And so there's a green premium to build with mass timber. What ARIA is unlocking is the value of that biogenic carbon storage in a building, and enabling building owners to receive a rebate, if you want to think of it that way, or carbon offset revenue for choosing at that critical time to build with mass timber instead of steel or concrete. The company just completed a pilot project with a major West Coast university. This is pretty timely because in about 2 weeks, you may be hearing a lot more about Aureus Earth, because it'll be publicly announced, all of the details of that pilot.
Excellent. OpenAir heard it here first.
Yeah, absolutely.
And so as you're working, it sounds like all of these tie in really nicely to the building industry. What kind of collaborations do you see from the concrete industry at a national or international scale?
Yeah, absolutely. So obviously it depends on which entity I'm talking about, but for Minus specifically, Minus was named a top 20 startup by the Global Cement and Concrete Association. This is a conglomerate of many companies, cement companies, global cement companies, the leading producers around the world. We were named a top 20 startup this year in 2020. And I will say that because the solution that we offer the industry, it's plug and play, right? It's just switch from digging up quarries, limestone quarries, to growing them. It's plug and play with their traditional manufacturing, and we're seeing a lot of buy-in from the industry. A lot of companies in construction, not only the cement and concrete companies, but many have pledged, made bold claims about decarbonization, and are doing everything in their power to get there. So we do see a lot of buy-in for sure.
Excellent. So we have our first question. It's coming from Chris Neidel. So Chris, whenever you're ready.
Yeah. One of the things I am curious about, that in my work on concrete policy over the last few years, is a huge barrier is just the caution, I guess, that's sort of built into the sector, particularly on the civil engineering side, where you might come up with the most amazing thing since sliced bread, but the process of trying to get acceptance in standards and specifications is extremely difficult. It can be very, very slow. So I'm wondering, materially, what you're producing here, is it so indistinguishable from conventional that it's not becoming an issue, or are you bumping into any barriers related to that, more the sort of specification and acceptance side?
This is an outstanding question. You're absolutely right. The cement and concrete industry and construction in general is a very conservative, risk-averse industry, because we trust our lives every day to those materials when we walk into buildings and drive on roads and bridges. What you bring up, Chris, is it's almost a good framework by which you could judge the barriers and obstacles a certain technology has to overcome to get acceptance. I'll use Prometheus as an example. Prometheus is developing a product, but it can't necessarily be so radically different that it can't meet existing standards for precast concrete, for example. And that's the pathway to commercialization, is to fit within some sort of standardized framework. For Minus and all of the other cement technology innovations, one thing we thought deeply about with Minus is, if we're successful, will the industry have to change their practice? Will they have to buy a new widget? And I know folks on the call are probably working on that, right? Where, what is the carbon capture solution at scale? And what we're offering them, instead of a new shiny device or an electric kiln for which they can make cement, is all we're doing is changing the starting material that looks exactly like the material that they already use. So our pathway to commercialization compared to other technologies, think Carbon Cure, think others that really have had to work with the industry to gain acceptance, much easier pathway because the end product looks, feels, behaves exactly like Portland cement at the end of the day. Aureus Earth, on the other hand, is trying to, there's a green premium associated with like building with mass timber and using low carbon concrete sometimes, but there's also risk. And so some building owners may not necessarily want to choose to build with mass timber because they've never done it before. They've never had a mass timber building. They don't have the right contractors to do it. So there's risk there. So the offset revenue helps ameliorate some of the risks and even the insurance premiums that some of the contractors charge for using something brand new. So I think the insurance conversation within construction is like a whole nother topic because that is a significant barrier to adopting these new technologies.
In the same vein, are you seeing, not just from the industry side, but like standards bodies, are they treating this like concrete? Do you have to go through brand new certifications? Do you have to do like life cycle and aging testing? What does that look like to bring this in as a replacement, even if it looks and feels the same?
For Prometheus, there are no exogenous standards, and that would take a lot of time, a lot of development, and a lot of lobbying. And that's just not a luxury that the company has or the investors have. We definitely want to get to market as quickly as possible. So that's where, I think there are other examples too, in addition to Prometheus, but Prometheus is finding the right standards to meet so that architects and building owners feel confident that, okay, this meets that minimum requirement. It can be used in a certain way. There are other companies that have tried similar things, who I won't name necessarily, but that thought they may have a product for the construction industry, but found that because it didn't meet those standards and it was perhaps too costly, that they had to find other avenues for entry to a market. Mm-hmm. Minus, on the other hand, since we're just growing limestone, all we have to do is meet the purity standards established by ASTM C150 and C595. And because a lot of the limestone quarries were made in exactly the same way that we're growing them, it's by these massive deposits of calcium carbonate produced by these microorganisms. We check that box, and it's actually almost too pure for the cement industry. So I think our instinct in both companies is to find the standards that already exist, and that's your easiest pathway to market.
Great, thank you. And we have Dahl Winters, who has a question for you as well, so bring her up.
Hello, pleasure to meet you. I've been doing some research regarding calcium-based carbon sequestration and removal. Done some studying about algae as well as other methods of removing carbon using calcium-based sources. And I was wondering, have you looked into LC3 concrete as a potential avenue for your product? Because I know it's not used as much now, but Portland cement seems to be, there's a limitation of how much you can add to it of calcium carbonate at about 6%. I've heard, whereas LC3 has 30%. So you can really have a great impact there. Is that something you're pursuing?
Yeah, this is great. I'm going to dispel a little myth for everyone on the call. So LC3 is a great marketing scheme. It comprises Portland cement at 55%, calcined clay at 30%, and then limestone at 15%. And then limestone was used to make the actual Portland cement to begin with. It is, people know it as LC3, but it is in fact a Portland limestone cement with 30% 30% of a supplementary cementitious material like a fly ash or a slag or a calcined clay. And of course, if you do the actual embodied carbon measurements, this is one of the lowest embodied carbon mixes, so to speak, in terms of the cementitious materials content. So we are looking at, we've looked at using the limestone in a couple of ways. One, as a filler in a Portland limestone cement, what's known as a type 1L. We're looking at it to make actual Portland cement, which is, the actual process of making the gray powder, and then also as these inert fillers in like an LC3, the LC3. So there are a wide variety of different uses for the limestone. It will ultimately be up to the cement producer and the ready mix concrete manufacturer, which are not always the same entity, to use our limestone in these various applications. It'll be up to them to choose. But this is a great question, Gal, because we're doing some experiments with our limestone in LC3 right now.
Wonderful. Thank you so much.
Yeah, of course.
We also had a question from Mike Robinson. Let me see if I can pull him up. Oh man, you guys are raising your hands and putting them down faster than I can bring you up. Rude. Mike, you should be able to talk, and I'll bring you up as a panelist. Well, he will be rejoining us as a panelist. In the meantime, Scott, I'll bring you up as a panelist and we'll cycle you up first. Oh, there we go. All right, Mike, take it away.
Great. Thanks, Gloria. Hi, Will. Great to meet you. Thanks for taking the time to talk with us. I actually had two questions. One is in terms of making progress with standards in the construction industry. Have you connected with the Carbon Leadership Forum at UW School of Architecture, working with them on their embodied carbon standards?
Yeah, it's a small world. So in 2013, I met Kate Simonin, and she had just launched the CLF. And a couple of years later, I worked with her and Aaron McDade from Architecture 2030, and we founded the Embodied Carbon Network, which grew into the CLF community. So since meeting Kate, I've been really, and then I was like director of the CLF global hubs and established the regional hubs. I stepped away in 2020, last summer, once the company started to take off. So I'm super familiar with Kate. We're great friends. We talked last week, 2 weeks ago. And so I'm really plugged into kind of the benchmarking effort that they're doing, their work with the EC3 calculator, which is like pulling in a lot of environmental product declarations to help designers and decision makers like understand like what's average, what's standard. So yeah, I keep a pretty good pulse on CLF. It's a great resource for those who are like kind of in the building space and carbon space.
Yeah, that's what's great about what they're doing, is that they are coming at it from the building industry perspective. So it's addressing some of those challenges you mentioned. I would love it if you could tell us more about the technology involved in I think it's Prometheus that does the Portland cement-free concrete. Are you able to go into some more details about that, description of how that works?
Yeah, and you know, we published papers, like, because I'm first and foremost an academic, right? I'm a tenured faculty member with my own research group at the University of Colorado Boulder. In 2020, we came out with our seminal paper in Matter. It's a self-press journal. You can kind of Google it and find it. But in there, it shows you like the basic premise of like how you make this material. And what we ended up engineering is this sand plus now it's like a proprietary hydrogel biopolymer-ish blend, like scaffold. We kind of took a page out of the biomedical industry that uses a lot of like hydrogels to grow cells, and they proliferate and they grow and differentiate. But all we did was like add a structural scaffold. So we added sand, just like you would to make a mortar or a concrete. And then we added instead of like stem cells or other types of human or animal cells, we added biomineralizing cells. So that added additional calcium carbonate to help cement the whole thing together, like biomineralized the scaffold, a lot like how bone biomineralizes. And we looked at a wide range of different microorganisms. We looked at Sporosarcina pasteuriae, which is like a natural biomineralizer. They don't use CO2. They actually use urea to make calcium carbonate. We took the genes, the plasmid from those types of organisms, and we put it in E. coli and engineered E. coli to do the exact same thing, which was pretty cool. And then we also took a look at natural biomineralizing strains of cyanobacteria. And that is ultimately what Prometheus decided to commercialize, because carbon-wise, it was really the only one that was using CO2 for the actual biomineralization, whereas the other two were using a sugar source or something like urea to undergo the mineralization. Was that enough detail? Or
Sure, absolutely. And Gloria posted a reference to the paper, so that's great. Thank you very much.
Oh, thank you. Yeah, of course, absolutely.
Thanks, Mike. Scott, you're up.
Hi, everybody. Thanks, OpenAir. This is amazing. And thanks, Doctor, for taking our questions. I had a question about Prometheus and the go-to-market strategy. Just curious, do you need to end up working with a small set of large buyers, or is this something where you'll be working with individual developers in the space? So curious about that, and what are the biggest challenges?
Yeah, since Prometheus raised its Series A round, it's kind of like having a child and then like sending it off to college, because I'm not intimately involved in the day-to-day. I was obviously a co-founder, and now I'm an advisor, so I don't get to spend too much time with them knowing exactly what the strategies are. I can tell you that at the end of the day, they're making product, and we have, and this is all public information, but as part of the Series A investment, the investment team included folks like Microsoft. It included SOM, which is Skidmore, Owings and Merrill, an architecture and engineering firm. It included GAF, which is a building materials manufacturer. But then it also an Autodesk, which is like a strategic construction engineering entity. But what's awesome is we have gotten a lot of press, and so there are a number of different types of customers that are reaching out. Folks like architects, which are serving the end use, developer, are wanting to know about products and specifications. There are building owners as well, and even consultants for those types of building owners that say like, hey, we want to use this material in these types of projects. You may venture to guess why Microsoft really wanted to understand the materials and made an investment. They have an interest in using them. So right now the roadmap is to scale production throughout the next 12 months, all the while ensuring that we meet the technical standards, and then laying on top of that business development and establishing these end use customer relationships. So I can't tell you more specifics than that, just because I'm not involved in the day-to-day. More information, reach out to Prometheus Materials, prometheusmaterials.com, if you're interested in learning more about that.
Thank you. Appreciate it.
You bet.
So we have a question from Marie, and I want to bring her up in a second, but Polly asked, just as kind of a follow-up, is what you're doing basically feeding or encouraging the naturally occurring organisms, or are you changing what you find? And so Polly, chime in if I'm not getting this correct, but my understanding is are you just using them to produce the limestone, or are you doing some change to them before you use that material?
Like engineering the organism themselves.
That's my interpretation. Probably feel free to throw a correction in the chat while I'm bringing you up as a panelist to dial in your question a little better.
Those familiar, what I can say is those familiar in the microbiology, synthetic biology, familiar with that space, there are a number of different ways in which we can condition and encourage naturally occurring organisms to be better producers. There's like two strategies. One is natural evolution, where you subject those microbes to increasingly different conditions systematically to get them to be really good performers in a certain environment that you really want them to be. The second way is to actually manipulate the genetics and to integrate different plasmids and genes that impart either better or even different capabilities to microorganisms. Yes, that's genetically modified organisms. We're growing building materials with some of them, or we have in some of our previous work. Right now, we start with naturally occurring strains, and that's where we are at present.
And are you, collecting different strains and picking the ones that you like, or are you kind of doing a trail mix of varieties and seeing who, I guess in this case, would sink to the bottom, maybe then float to the top?
Yeah, we're doing a very systematic study and selection of strains. So for minus, especially the microalgae that we're using, there are a host of different species. There's only a couple that have been really thoroughly studied, but there's a host of different species. We just won a $3.2 million Department of Energy ARPA-E project with our partners at the National Renewable Energy Lab just down the road and the University of North Carolina, Wilmington. It's a 3-year effort in collaboration with Minus Materials to commercialize the technology. But in the scope of that project, we are doing quite a bit of artificial strain selection, that natural evolution, growth optimization, and even doing some metabolic engineering of the microorganisms. So I think in 3 years' time, the answer to this question will be slightly different. But the ultimate goal of Minus really is to become the world experts at farming these calcareous microalgae at scale, specifically for carbon dioxide removal. And there's an added benefit of solving the cement industry's problem while we go.
And as an electrical engineer, metabolic engineering, is that controlling the environment and what you're feeding them, or is that something internal to the algae themselves?
Yeah, it's internal to the algae. So what you just described, yeah, I think you can still hear me. What you just described is that natural evolution. Like if you change the environment, there will be some cells that don't survive and some that do. It's evolution, right? Natural evolution. Only the strongest and fittest will survive. But there are synthetic biology techniques where you can integrate bits of DNA to cells that when they multiply, they'll be kind of zipped into the genome, and then they'll be imparted with different activities. Really, the classic, by the way, like insulin is made this way, like the genome of a bacteria to make the compounds found in insulin, like all insulin is made this way. And we kind of did the same thing with E. coli is not a natural biomineralizer, but if you input what's called the urease like plasmid found from other organisms into E. coli, the simplest way to do this is a process called electroporation, where you more or less shock the culture, and that opens up pores in the membrane of the cell, and that more readily uptakes bits of DNA or plasmids, et cetera. And sometimes it's successful, sometimes it's not, but it can be, again, used to enhance something that's already there. So adding more copies of different plasmids, or imparting new features to organisms.
Got it. Thank you. Marie has a question. You should be a presenter now. There we go.
Hey, yeah. Hello from the UK. It's quite a bit later here. So I'm an architecture student, and I very much have like a design background. So this conversation is very much kind of above my level of understanding of material science, but it's something I would really like to learn more about. Can you recommend any resources for someone starting from complete scratch to learn more about these processes and these technologies? Books, articles, videos, whatever, anything like that?
Yes, I'm an academic at heart, and most of everything that we write is extremely technical. But what I will share is a recent article. I'm Googling it now, and I can drop it in the chat. This just came out on Monday, but I think it's from an outlet called The Conversation, where academics write to more of a public audience, still using scientifically rigorous referenced data. And this, I think, will be really great to help just paint a picture of the carbon problem with concrete specifically, and everything that's kind of going on in that space. And then I believe if there's anything that you want to double click on and like look more into, then searching for similar phrases that describe that type of technology is the way that I would go.
Sure. Great. Thank you.
And then we had Peter ask a question. If you, Dr. Srubar, could discuss some of the market and opportunity for, I assume primarily Prometheus, but I think they all touch on this, for the potential scale of carbon to be sequestered. How much climate restoration is possible with your approach? What's the total market? Whatever you can kind of lean into without hitting the secret sauce on the slides that you're giving to your VCs.
Yeah, let's see. There's a lot I could possibly say here. So, like I said, cement production alone, I think I said this, is responsible for 7%, right, of global CO2 emissions. Construction materials specifically is like 11%. So it's significant. That's huge numbers. We're primarily fixated on the cement industry, so that's like 7%, right, of global CO2 emissions. If we've made some calculations, like if the world would adopt our limestone technology, and just assuming 100% market capture here, which is obviously a theoretical maximum, we would help the cement industry reduce their emissions by 2 gigatons of CO2 per year, which is huge. In addition, if 15% of all cement is replaced by ground limestone, like in this Portland limestone cement application, or like even a LC3 cement application where you can put just put the raw limestone, that helps store an additional 250 megatons of CO2 per year. So those are theoretical maximums. Obviously, like whatever market share we get to, that's the percentage of those emissions that we can help either help avoid or permanently capture and store.
That's great. Carl, are you able to unmute? I'm going to ask for Carl. He's wondering if there's regulatory factors or considerations for the release of developed or engineered strains into the greater environment?
Yeah, obviously genetically modified strains. And that's why you can venture to guess what Prometheus is using, because it's easier to get into the market without those concerns. And there are certain consultancies, regulatory bodies that do govern that. But if you are really building a technology based on something that's naturally occurring, much easier pathway. I think the way that we like to describe it is, a lot of the algae, Gloria and Logan, you know this, like it's like the algae that are growing in your fish tank. It's like innocuous. Some strains and blooms in certain locations can be dangerous environmentally, but that's not necessarily like that. That's not the process that we're industrializing. Like we're controlling it a lot differently. So certainly something that we keep in mind. The regulatory space is not my area of expertise, but I know that there are protocols in place to ensure the safe placement of those types of organisms.
Great,
I will say just anecdotally, launching a biological materials company like Prometheus in the middle of a global pandemic where everyone was really averse to biological agents was interesting, but it turned out not to be a significant barrier. So we were pleasantly surprised.
That is definitely a good surprise in the midst of the chaos. Kind of analogous to the regulatory space, but if you look at the innovation ecosystem surrounding living materials and carbon sequestering materials, what do you see as the gaps in that ecosystem, whether it's advocacy or policy or funding, that would help move that space along and really develop into a viable part of the solution at scale?
I could talk for an hour on this question.
Well, you have 15 minutes, so.
I know. I would say first and foremost, like cost is always a barrier in my world, right? Construction is a commodity market. So any type of incentive, whether that be government or whether that be the public, private markets like carbon offsetting, they're very important to help pull some of these decarbonized materials into actual practice. On the living materials side, this is really interesting, and I encourage all of you, to dive a bit deeper. Not all living materials are inherently good for the environment. There are some that have significant carbon footprints. So I think that just like there are good and bad bacteria, that are threats to us, there could be good and bad living materials that are good and bad for the environment. I encourage my students and anybody I talk to just trace the CO2, like trace the carbon. Where's the carbon coming from? If it's from something like a sugar, or a complex sugar, or something that is not necessarily traceable back to a CO2 molecule, got to kind of step back and scratch your head a bit and think about that. So I think I would say cost, I would say, risk in our space. And then I would say on the engineered living material side, just to summarize the approaches, because then scale and cost, risk barriers then ultimately follow that.
Sounds good. All interconnected as those ecosystems are. So there's 10 minutes left. If anybody else has a question they want to throw in there, we've got one from Chris, and then I have one more I'd like to ask. So this is your guys' last call to get something in. Chris, you want to go ahead?
Yeah. One thing I wanted to just raise, and you've kind of touched on some of it already, or implied it at least, is that, in OpenAir, I think you're familiar enough with it. A big part of our community is involved in open source citizen science and R&D projects. And then the other half is involved in advocacy. So we've developed a lot of legislation, gotten it introduced in different states, and now over in Europe. But we also have a kind of a category of activism that's arisen called like activist business development, where we try to think, is there a cool, amazing company with a great solution that has some needs that could help close a gap or make an introduction or advocate for a very particular barrier to get it out of the way, crowdfund, so, it's just so exceptionally cool what you're doing. And I wonder, is there anything that you could think of that an activist community, so described, could help you in your ventures in any kind of way?
Oh, wow. First, I mean, that's tremendous to know that power really exists. I think that any help on education and advocacy is huge. I mean, the Carbon Leadership Forum is really leading the way here and educating developers, building owners, building designers, architects, engineers on the significant environmental impacts of our buildings. And it's not just carbon. We spend 90% of our time indoors. In Boulder, Colorado, it's a little less, but for the vast majority of the world, we spend 90% of our time indoors. So what's in your walls, right? What is in your walls? And do you know? And this gets into the living, healthy, plant-based building conversation that Prometheus is really trying to start. There's a great Time magazine article on Prometheus and following the algae brick road to plant-based building, I think is the title. So I think that there's just a lot of education around, okay, yes, the materials we make today, the material decisions we make today will impact everyone who walks into this building. Think of schools, right? Think of schools and where we send children to. So I think there's still a lot of advocacy and education that needs to happen, as well as planning meetings, and asking, what are city council meetings, like what is the city doing regarding embodied carbon? Like we're seeing a lot of activity on the West Coast, but like very little in some in the Northeast. But I think it does take a grassroots effort to educate. Hence the carbon leadership regional hubs, because there's some activity as well set up around the country and even other cities around the world to get that grassroots education, advocacy, and start these conversations. But if I think of something like really specific, Chris, I'll reach out to you.
Yeah, definitely do. And including like we have almost a sort of a fan club vibe with certain things where if there's we should try to get more of our members to follow you on Twitter, just amplifying messages that are coming, although you're pretty good at getting well-deserved attention, I know, for your awesome work, but just give it some thought and think creatively about it and let us know. And maybe there's ways that we can, help out.
Awesome. Yeah, appreciate that.
And in the vein of the OpenAir Collective fan club, we do have a new algae channel on the Discord server. And one of the projects there is talking about what would a DIY photobioreactor that people could have in their homes, and the goal is maximizing carbon capture. So we don't necessarily know what we do with the algae, but I'd love if you have any hot takes as we're closing out on what would you recommend for a bioreactor that people are going to put in their homes, and what might you suggest for some of these algae use cases?
This is so funny. About 2 years ago, I was thinking if everybody in the United States had some capability to grow algae, what does that look like, and how could we collect it, and what happens to the biomass? I think we're working on this at Minus. Like we want to develop ultra low cost ways to grow algae, because we're not making super high quality compounds. Like we're not necessarily growing algae for like high quality lipids. So we're thinking about the exact same thing. Think about a fish tank. Think of it's exactly like a fish tank. The things that you put in a fish tank to kill algae, just take those out, and they'll grow naturally. So that would be my first suggestion, is see if you can have an algae tank and see how dense you can get that to grow, and look up some tricks of conditions in which algae like best, in which they like to grow, and what nutrients do they need, what nutrients should they probably not have, because there are other environmental impacts with some of those things. So I think we need a new line at PetSmart where it's the fish tanks and then the algae tanks.
You can actually look behind Logan and see our algae fish tanks. So
this is
we have
awesome.
some.
Yeah, I love that.
What are your thoughts about using algae as a biomaterial in like 3D printer filament or other bioplastics?
If you're just using the raw algae, it's kind of an inert filler. This is the other thing we kind of sniff out. There are some companies that are growing algae and putting it in things just to put it in there. It doesn't have a functional use. And I think that's okay. But the beautiful thing about algae is that they capture carbon. And you want to hold on to that, right? The longer you hold on to it, the more value it has. It's like flattening the curve of carbon emissions, right? So that storage piece is really critical. If you put it in a filament, my next question is well, what are you going to use it for? Is it going to be used to make something that's going to last a week, or something that's going to last 100 years, right? So there may be better uses for biomass to help solve the climate crisis. So I would think about functionally, what is it doing, and actually, is this going to be around for a long time? Okay. Of course, the next question is if you're displacing an equivalent volume of material but getting the same performance, then yeah, that's a good idea, because then you're avoiding the emissions of that polylactic acid, which, depending on where you get it, is actually okay. But yeah, I would ask those questions of, functionally, what is it doing, and does it make sense if I pull this out and put algae into it? Am I really doing something good?
Mm-hmm. Yeah, our hope is to maybe use our little DIY algae bioreactors and put them into our DIY algae fermenters and pull our PLA right out of there. So we'll see what happens. This is the last call for questions from the audience. All right. Do you have any closing thoughts you'd like to share, or things you'd love to see from the CDR community at large that we could help collaborate on or bring to bear or share around?
Every time I talk to Chris, I'm just energized because I know I'm not alone, right? And I think that's what this community has. It's really special, is that we're all in this together. So my parting thoughts are: keep fighting the good fight. Let's lean on each other and help each other where we can. And it's only the beginning, right? This is a life's work. So keep it up, and I really, really appreciate talking with all of you today.
Thank you so much. We really appreciate you being here, on a Friday afternoon when the weather is really cooled off. So it's great to be getting outside. So hope we aren't keeping you from your weekend, but we're so grateful for your time.
Thanks, everybody.
Thank you so much.